Great. I think we can start now. Can you guys see my
You want to
screen?
start? Oh, let's do it.
Yep, gotcha.
Cool. Yeah. So, welcome everyone to this month's community call. Um, we have a few things on the agenda. So, first off, I'm going to talk about one or two things that have been happening around cadCAD. Um, then Chris is going to give a few updates from the Cortec working group. And finally, we have a presentation by the Active Inference Institute on Active Blockference, which I'm really excited about. Um, so yeah, cool. Let's get started with the first one. Um, we have first the cadCAD study group, which is held at the Token Engineering Academy. The new program is going to start August 9th, so next Tuesday. It's now going to be just 1 hour long from 5 to 6 p.m. UTC, and the primary focus is on introduction to complex systems using tokens. Also, the Block.Science Labs is giving participants of the study group free platform access and $50 simulation credits for the duration of the course, which is pretty nice in my opinion. Um, Continuing with token engineering, we now have our official release date for the token engineering fundamentals course. That's going to be during DevCon 6, which is from the 11th to the 14th of October. Um, for those who aren't familiar with the course, is the first comprehensive course with certification on the token engineering field, and they are working on a matchmaking program for it. So yeah, really cool. Then cadCAD was also present at FCC, which was in Paris last month. Um, Bogan Radu, which is the CTO of Mento, they work with stablecoins on the Solo blockchain. He gave introductory workshop to cadCAD using the Predator Prey demo with a fun analogy with Pokemons and Pokemon trainers. If there's anyone here who's just getting started with cadCAD, I think that's a really cool video to try to follow along and just learn a bit more about cadCAD. And finally, grassroots economics, the Danish Red Cross and Block.Science worked on modeling community inclusion currencies, and that work was now published as a PhD thesis. And so if that's something that catches your attention, I'll be sharing links in this presentation after the call. Um, and that's it for the CAD ecosystem. I'll now pass it over to you, Chris.
Cool. Thank you very much, Andy. Cool. So next slide. So just some updates from the Cortec working group. We meet every 2 weeks on Wednesday. We just had our meeting right before this call, so the next one will be in 2 weeks from now. Next slide. So the roadmap, we're wrapping up blocks and points to both sort of like co in progress, but blocks is wrapping up imminently. And once blocks and points are done, then the ability to define and express models in cadCAD reference will be complete, and it'll be a really good interaction point for a few of you that I've already spoken to about this on the call to start giving real in-depth feedback about the project, how it feels. We've done a lot of work, and most of the thinking about this has been about the user experience of interacting and expressing models. So would be really excited for that feedback. Next slide, please. So just as a refresher on what we covered on last month's update, we had completed spaces and made them a hybrid of types and classes and simplified the UX towards building digital twins. We sort of contorted the way that Python works to enable this. So we're really proud of that work. Emmanuel, who I believe is on the call, is just a rock star, superstar. Give him all the props, Tyler as well. And it's a lot of advisement from Z. So next slide, please. So for this month, we've reached a decision on signatures of block functions. Points are now specializable types. One thing to note on points there is we did work to enable potentially getting a static analysis actually done here. There is future work we have slated for actually checking the feasibility of doing static analysis, but by doing this work, one of the nice sort of bonuses we got was if static analysis works, we get it on points. And third thing that was resolved was blocks are decorated to transform Python callables into a block. The spec is complete for that. So next slide, please. So we're working on doing the actual work for the blocks as decorators. Getting the formalisms for the algebra spaces is underway, so now we're getting full advisement from both Zargam and Jamshid Shorish, who did the white paper on generalized dynamical systems. We're ensuring that it's all like theory correct there. And last, we've started assessing the piping logic. That's going to be similar to, we're looking at airflow as sort of inspiration there, really looking more for the syntax rather than logic, because we want to schedule based on events rather than just sort of it being a cron job. And that we figure enables the ability to get to manipulate DAGs without them having to be necessarily complete before being able to work with them, and to link between DAGs so we get more of that modularity. That's always been sort of a cornerstone of this project. Next slide. And so future design challenges, as was covered on last call, just getting the pipeline of blocks, the visual language of it. We want to stringify it. We're looking at symbols that will be logical to use, and then tie that into visual cadCAD, which is a GUI-based model builder that Labs has on our roadmap. I think we did a bit of a teaser of it before. We're really excited by being able to break ground on that. And then second is the feasibility research of the static analyzer, as I mentioned before. So that's what we've been up to. You can check the repo. We've got a bit of project management there now with GitHub issues, so you can check the state of the project at any given point in time. Love community engagement and feedback. So yeah, really excited about the work the CoreTech team has been doing. Thank you.
Cool, thanks. Now it's the time for the Active Inference guys. I'll hand it over to you guys, and let's see what you guys have for us today.
Well, thank you everyone for joining live and for listening in replay. Really appreciate the opportunity to share our project and welcome anyone who'd like to participate into it with us. I'll first just connect to a few threads from what was just mentioned, then describe a little bit of an overview. Sorry, Chris, I can hear you. And then we'll talk about some different developments in the Active Blockference project, and who knows where it will go. Maybe we'll screen share and show some notebooks. Maybe we can have some questions, and so it'll be great. So just to provide some overview context and really resonate with a few threads that were presented in the community's progress, the static analysis direction is exciting. And as we'll be unpacking in this conversation, what we hope Active Blockference brings to the picture is a cognitive modeling approach, an entity model that's consistent with cognitive modeling that could be within cadCAD simulations, not just as a top-down perspective, something like a mean field approximation across entities, but to embody cognitive diversity in multi-agent simulations, and also entities that could do things like parameter sweeps across cadCAD parameters. So thinking about cognitive points, paths, and state spaces is very interesting alongside system points, paths, state spaces. The mathematical formalisms was also quite interesting to hear about, and will in the coming years be interesting to juxtapose with the kinds of approaches that Active Inference takes towards dynamical and stochastic systems. And this has also been a conversation unfolding with Z over the years. And then lastly, the visual language, the CAD 3 was very nice and something that we've thought about for graphical modeling in Active Inference. To give some context, it's really interesting to see the development of all of these communities of practice and frameworks and approaches to complex systems modeling. And really positive to see, for example, that in your learning group, there's also been participants at the same time in some of our learning groups at the Active Inference Institute. So I hope that we can just continue to develop on this multi-scale journey that we're on. We do have some points to cover and address, but again, there will be points and time for questions, and feel free to use that cadCAD community channel 2 rows up from the voice channel to write anything in there. Also, in my Discord profile, you can join in to our Discord if you'd like to and continue the discussion that way. And this project, like others at the Active Inference Institute, is a participatory project. The code repo is open source, and there's many other aspects that are not necessarily so code-centric. And we have meetings on Wednesdays. There's 2 different time slots for meetings. So again, just would encourage that anybody at this point or later on in the call or in a future moment, they feel excited to learn more, reduce their uncertainty, act, infer, serve, then they're welcome to get involved. Also, this project is connected to some other works in the Institute related to, for example, an active inference ontology and some knowledge engineering approaches. Okay, so on to Active Blockference. The link has been provided in the text channel. The simple description of what Active Blockference is that Active Blockference is implementing active inference in cadCAD. Today, we're going to be discussing some aspects of the work that are variously technical, conceptual, and applied. We'll provide a little history and an overview of active inference and so on, but the short technical overview there is that emerging from a background of active inference simulations that were almost entirely done in MATLAB, more recently, there have been Python and Julia implementations. Our assessment some time ago was that while these Julia and especially Python implementations provided like the kernel of the active inference entity model, which we'll talk more about, various features were being brought to the table by cadCAD, and we're going to have like some points on what active inference brings to cadCAD and also what cadCAD brings to active inference. Additionally, we have a paper that's been accepted at IY, and I'll post the link there, that is going to be introducing active blockference into the active inference and also broader machine learning community. It's at a European machine learning conference. And as with this conversation, it's all to be building bridges amongst our communities of practice, computation, theory, etc. Before we go into introducing active inference, one of the primary developers and the first author of the accepted paper is Jakob. So Jakob, if you want to just give any overview thoughts before we move forward.
I guess I can kind of extend that invitation to participate in this project because even though we've been having discussions for a while now, the project is still definitely very early in development, and there are a lot of exciting areas to explore that in the current in the current size of the participants can't really be explored that in depth. So it would be great to get more people who are familiar with cadCAD, who perhaps want to learn more about active inference, involved in some of these projects. And I think, as Daniel will probably mention, a lot of these projects aren't necessarily centered around like cognitive modeling. It's more about building these reproducible tools that are using both the cadCAD framework and active inference agents in
novel scenarios. Any anything else I think would be going into some specifics, which I guess we'll cover later.
We have a meme in our community. Well, we have two memes. The first one is the guy with a Pampit phone, and it says, "When I say GM, I mean generative model." And the generative model is a core concept in active inference. And then another meme for us is like, it's a Plato's cave situation. Can you make a 2-minute video? So I won't even attempt to give an overview of all of active inference. And there's a lot of educational materials we've already co-produced and will continue to create as a community. But to ground active inference with a cadCAD, at its core, active inference is proposing an entity modeling approach, and it is the simplest possible partitioning on a Bayes graph of what a thing is. It's the partitioning of figure from ground, and it rests upon a Bayesian graphical framework, so Bayesian statistics and the causal network approach of Pearl, 1988. And that entity model can be seen as, or can be modeled as, or you can apply this model to, without tripping every philosophical landmine. That entity model can be seen as an input-output system. That could be two agents that are coupled to each other. It could also be an agent in coupling with its environment. And the partitioned states are known as internal states, external states, and blanket states. The blanket states are the states upon which internal and external states are insulated, or technically that are conditionally independent. And then we go one step further into the blanket states, and the Markov blanket and the idea of blanketing states on Bayes graphs was introduced by Pearl in some of that earlier work on Bayesian graphical computation. And some people call this a Friston blanket, named after one of the major proponents over the decades, Carl Friston. And in the Friston blanket, we move from a kind of undirected graph Bayesian insulation framing towards an input-output framing, where the input from the perspective of the internal states are called sense states, and the outputs are called action states. And this is a story about active particles, entities, which constitute generative models, and they consist of the particular states, the states that make up that active particle, which are the internal states and the blanket states. So, the brain and the body. Coarsely, and people nuance that. Active inference provides a first principles approach to modeling that thing, that particle, that cognitive entity. And that's why many connections have been and are being drawn to generalizations of what is called Bayesian mechanics, seeing classical mechanics, statistical thermomechanics, and quantum mechanics as being variously different aspects of a Bayesian generalized cognitive-ish situation. There's a lot there, and that was not even the hopefully best way or final way that we'll say it. And that was just one voice sharing one linear string. So again, I hope if that is like curious topics or links that you learn more. And also, as we continue forward, it will get more and more operational. And that is one of been the background excitements with using cadCAD, and especially being able to play some of our notebooks out in Block.Science Labs platform, is to go from concept relationships or equations, analytical relationships, into the implementation and hinting ahead to what cadCAD brings to active inference. The execution order turns out to matter a lot. And one can imagine like a multi-agent setting, if you have all of the entities decide what to do and then implement it, you could end up with collisions that might not occur if you had one move first and then the others. But then if one is always moving first every round, that is like an unfair situation in other ways. So that space of execution order and the full stack of the execution order, from the graphical accessible representations on through the reproducibility that cadCAD provides, in our opinion, is going to be really essential for accessible and rigorous active inference deployments. Active inference has been applied in many areas directly to cognitive modeling in the case that it arose from, which was like sensor fusion in neuroimaging and behavioral research and neuropsychiatry. And over the recent, say, 5 to 15 years, there has been a lot more expansion of active inference into areas that we and others have worked on, ranging from online teams and communities, ecological communication dynamics, and just many diverse areas, some of which we've highlighted in our Institute's live streams. Others can be found through searching through the literature. But more and more people are using active inference as an integrative approach to multi-scale complex systems, again, which fits so nicely with a multi-scale and heterogeneous component approach that cadCAD's providing, vectoring in from a generalized dynamical framework on the analytical side and the systems engineering approach from the implementational side. We mentioned earlier that there are a few different computational approaches to active inference that exist today. MATLAB, there's a Python package called PyMDP, which is what we have used heavily in terms of the implementing active inference in cadCAD. The implementation has largely come from PyMDP's nucleus. And then there's also some Julia implementations, such as ForneyLab.jl, which brings in a few other twists and tricks like variational message passing. But so far, we've been working mainly with the PyMDP Python side, although we're excited for future Julia developments. That's where cadCAD enters as a wrapper and an enabler for active inference models. And also as a corollary, perhaps, Block.Science Labs enters as an approach for us as a participatory online institute to use cadCAD models in a real-time way and make them, again, accessible and reproducible. The next two areas that I'll mention are what active inference brings to cadCAD and what cadCAD brings to active inference. So I'll start with what cadCAD brings to active inference with just an appreciation to the tool, and then that will turn towards some of the already or future ways that the active inference loop could close, and some interesting directions could be brought back into cadCAD. Jakob, thank you for posting the critical meme. Again, some say it's the funniest meme. Not everyone says that, though some do. So again, please write any questions, and we'll have a time for any thoughts or questions after the next two, like in between and after the sections. What active inference is gaining from a relationship with cadCAD, and what active inference brings to cadCAD. And these are kind of like the two pillars of our approach, and also hopefully frames it as like a win-win, because we do believe it is that way. So what cadCAD brings to active inference. Fundamentally, cadCAD is providing a framework with various features already and in the future that are needed, helpful, or even innovative for the implementation of active inference simulations. cadCAD pulls back quite generally from, again, that systems engineering angle and the generalized dynamical systems angle, as does active inference. And then from that pulled back 30,000-foot view, cadCAD brings a few pieces to the active inference model implementation that to engineer ad hoc would be unrealistic for a team working on like a specific target system or system of interest. Anyone familiar with the complexity of cadCAD would know that these are either features that you implement partially or don't think of, or think of but lament, or implicitly don't do, and every other possible combination. So to give a few examples of the specifics of the kind of features that we think could be deployed in active inference simulations, from the toy simulations on through the real-time decision support, are the specification of intra and inter block execution orders. That really takes our field quite a ways from formalisms and framings of the perception cognition action loop, like a graphical loop layout, or even the analytical equations that relate these different terms, translating that into code realization fundamentally. Just from a graphical feedback loop of entities in interaction with their environments, where's there going to be a for loop? While what? If what? Those, the team will find themselves at square one, and also without a technique to even scan across different opportunities. Additionally, the setting of complex cyber-physical systems is one where cadCAD has already found a home, and we believe Active Inference will have a role to play there too. So taking extant cadCAD simulations like the Ethereum models and others, and figuring out how the ontologies of cadCAD and of Active Inference relate to each other, I think is going to be quite fruitful. cadCAD offers reproducible simulation environments for science and application, decentralized science, DeSci, yes, but also just more generally research and analysis. And the reproducibility is essential for making a simulation, whether it's going to be more epistemically oriented and research directed, or whether it's going to be used for decision support. Very critically is that cadCAD provides the parameter sweeping and optimization over model parameters, which from our perspective might be framed as like a meta Bayesian modeling, because the cognitive models and entities themselves are Bayes graphs. And then there's this level of the experimenter or systems designer doing parameter sweeping across those cognitive parameters. And to kind of hint at a future benefit that Active Inference is going to be able to possibly bring back to cadCAD is we understand cadCAD to use sampling-based Markov chain approaches, which for large computational state spaces are absolutely important. Active Inference, through the first principles framing and the particular partition, enables the use of variational inference, kind of like a variational autoencoder. So again, not something that was invented by the active inference field, but rather something that is already in use in terms of variational autoencoders that are minimizing free energy terms, like the evidence lower bound, to bound their surprise on sparse or large data sets. And we're quite excited to wonder if variational inference and cognitive model-driven parameter sweeps could be done across cadCAD situations, and bringing in all of these non-sampling based approaches that active inference offers, like gradient descent methods and the variational methods more generally. We wonder how those kinds of tools that exist analytically and also at a basic implementation level in active inference might have something to share with cadCAD. And then just lastly, cadCAD provides a standardized format, approach, documentation, training. We've really been inspired by the cadCAD education efforts. And other than just saying, well, here's an online course on Python, and then here's the step where you're going to be modeling active inference in Python, cadCAD's going to provide like a ladder or a bridge where it is going to clarify the order of how things are defined in our simulations and elucidate degrees of freedom and ways that the model can be interrogated. And we believe that will help with accessible education as well as with advanced uses. So those are some of the points of what we think cadCAD brings to active inference. Jakob, if you want to add anything, or if anybody wants to ask a question or provide a thought there, or write it in the chat.
Yeah, I think the partitioning of the model into discrete blocks and the option to experiment with different architectures within cadCAD is one really exciting avenue of approach, and also the kind of combination with the modeling framework that kind of takes a more structural approach than traditional active inference modeling has done so far. In our discussions, we're often framing it as a sort of micro versus macroeconomic view on simulating these systems, where cadCAD has been used quite extensively for the macroeconomic population level simulations, and active inference, on the other hand, is more agent based. I think this combination can provide a kind of new can combine these two modeling frameworks to some really cool applications.
Sorry, I don't see the
Yeah,
hand
Tyler.
thing here.
Go for it, Tyler.
Yeah, it's just real quick, and I apologize if this has already been covered and I missed it, but are there some specific fields or categories of systems that active inference as a process or whatever you want to call that is best suited towards? Or is it pretty general in its use case?
A great question and very important to answer. A few aspects of the answer. First, check out the link with the live streams posted below. That will provide some sampling, ironically, of different use cases and settings. If I had to give a more narrow response, it would be it has specialized in single entity cognitive behavioral modeling. So one person in the fMRI, one rat in the T-maze, one decision maker allocating across a portfolio of strategies, for example. Simple or complex cognitive entity, but has largely focused on the single actor case with some limited forays into multi agent settings. For example, in 2021, I worked with colleagues on a ant colony simulation, and that was introducing some environmental effects and some multi-agent components that hadn't been used prior. So because it came out of this neuroimaging lab and context, most has been done on, again, those single entity cognitive modeling, visual reading, ocular motor, affect, all these kinds of kind of single entity cognitive features and decision making associated thereof. But in the recent years, people have speculated way, way, way further, and now there's gonna be a lag associated with those implementations. Though many startups, or several at least, are working on those, like in robotics and beyond. And I'll also post in the link to the symposium that we had this past weekend, which was on robotics specifically. So you'll find 9 presentations of those who are applying active inference to the robotics case.
Awesome, thank you. Actually, you know what? I got one more if I can. Have there been facets or features, I guess, of cadCAD that have kind of worked against the strengths of active inference? And I guess as a second part to this, are there features that if cadCAD had, or if they perhaps worked differently, that would enable a lot more power out of sort of the junction of these two things working together?
For the second question, I hope that we'll all continue the conversation and continue to ask, because we've really been just honored to see the flexibility of like the platform and the package. And so we'll hope to give you specifics there. And then to the first question, perhaps not working against a strength, but revealing what some claim to be a strength and revealing it to be less strong or less close than some expected. And the key example for me is the execution order. For example, when it's just equations and graphics and prose, it's easy to be like, we have an integrated model of perception, cognition, and action. It works in discrete time, continuous time. We have these analytical guarantees. It's the path of least action. Okay, what order does the entity interact with the environment in? And without those implementational details and the ability to specify and sweep across them, there's a lot of groundwork from the analytical prose and graphical representation to the implementation. And I really feel, for me personally, and I hopefully others too, the implementational supply chain from where a lot of the discussion had been to where applications are had been underestimated or just not totally recognized.
Interesting. Awesome. Cool. Thank you.
Jazzy or anyone else, do you have a thought there?
Yes. I guess one, thank you, Jakob, for sharing this paper. I guess one question I have is just, have you guys done any work with prediction markets? I'm guessing no, but if you have anything you want to clarify there, or for someone else in the community, that would be great. And then I had one other question, but why don't you address that one first?
I don't know of any specific prediction work or models. However, we have several Web3 directions that we can talk more about after the next section. So your second question?
Is just how active inference relates, let's say, to other AI modeling systems, broadly speaking.
Also a great question, and one that we hope to flesh out and have like URLs for reinforcement learning and active inference and adaptive resonance theory of Grossberg and active inference. Depending on how far or close you situate yourself, there are way more similarities than differences. But one major difference might be the first principles emphasis is oriented active inference towards like few component graphs. Sometimes those graphs hide like neural networks inside of them, but they don't have to. And so this is not like a big data billion parameter situation, although people are using it in cases where those types of models have been used. So I hope to flesh that out and clarify that and align and intercalate active inference with all these other threads and be clear about like what is it contributing at, versus other frameworks, reinforcement learning and otherwise. Thank you though for those questions. Okay, so to get to the topic of what active inference brings to cadCAD, and to note both of these directions of value being provided will be benefit. We're all somewhere in that quadrant system of familiarity with cadCAD, familiarity with Active. So from those who are absolutely beginning at both to those who are going to be in some space location where they can push the frontier, like everyone is welcome to contribute and learn more. And many things don't require vast expertise in order to contribute greatly, especially questions and clarifying ideas. So here's what we hope active inference can bring to cadCAD. Fundamentally, it provides an entity model and a first principles entity model that helps us model different systems. And I'll, on that first point, let Jakob, with more experience in token engineering, unpack a little bit your earlier point about the macroeconomic and the microeconomic relationship in the token engineering context.
Yeah, so this kind of builds on the difference between different modeling tools that are available within token engineering as well. I personally started working within token engineering with Token Spice, which was developed for initially for Ocean Protocol, but now it's a quite a general tool for smart contract audits and agent-based modeling of Web3 systems. And I think that's that the difference between Token Spice and cadCAD is in a way similar to the difference in the modeling framework between cadCAD and Active Inference, in the sense that Active Inference deals with specific agents that are performing actions in some kind of environment. Now, even though the formalism is pretty general and we can have entire systems that are sort of like active inference agents, there needs to be this kind of partitioning between what constitutes an environment and what constitutes an agent, which might be a bit different from the modeling framework that's been used, at least from the models that I've seen in cadCAD, which employ this kind of structural approach where you first need to figure out what the structure of the system is, and then you do a massive parameter sweep or Monte Carlo simulations across the systems to understand the different extremes and the different outcomes that you can have within that system. So this is kind of more about modeling the single path of a single agent or a single entity within that model, rather than um, looking at what are all the different possible outcomes within that model. But at the same time, the structural approach can be applied on the actual generative model side, where we're doing parameter sweeps or Monte Carlo simulations on the actual priors of that Bayesian model to figure out what the optimal parameters are to traverse that system to some preferred outcome.
Thank you. And to add a few examples and points there, then continue on. If one were involved in modeling like a staking ecosystem or something where some percentages were being varied for whatever reason, one could use macroeconomic curve matching and balancing to have that top-down view. But how will agents act? Well, how diverse cognitive agents act depends on cognitive parameters. Ultimately, attention, memory, expectations and preferences for the future, their own conceptualization of affordances, their capacity to compare policies, which, a little funny and confusingly, a policy in active inference is a sequence of multiple actions that are taken, which is related to the cadCAD definition, but that's an interesting ontological bridge there. And so we imagine that various settings that have been amenable to a macroeconomic, which is ultimately a mean field approximation to, for example, validator dynamics. If the reward goes up by 1%, then how will the population's mean perform? Well, yes, but how does the variance perform on the population? And what if this many percentage of people aren't paying attention? What if the attention distribution looks like that? What if the joint attention preference distribution looks like that? That's where we need to do parameter sweeps and investigation of cognitive parameters alongside. And so it's really like a top-down systems view. And then in that top-down kind of go-kart or bumper car electrified platform, we have the entities that are making their decisions and acting, whether in a design anticipatory way or even in a per agent like digital twin type setting. So that, we believe, is one of the key pieces that will bring value back into cadCAD models, which is to provide this bottom-up view from the inside, agentic perspective that will be amenable to data fitting per actor and their paths rather than at the mean field top-down. We mentioned earlier that ActInf could be used to implement several computational accelerations, ranging from cognitive-like entities doing cadCAD parameter sweeps that ultimately do a Markov chain sampling approach. So a deep generative model of the state space, which parameters are being swept in, and having low attention or low prior on some regions of the phase space. I'm just not interested in investigating this area. I'm investigating this area more attentively. And a further bridge than cognitive-driven sampling approaches would be the full implementation of the variational techniques and message passing that exist in active inference in some locations. And this ties to questions that we've had for a long time about cadCAD, but we'll come back to those closer to the end. Another area that builds from that agentic perspective for tokenomic systems particularly, it's related to an Ethereum Foundation grant that our team proposed, submitted, did not receive, but it was a great developmental experience. And this grant hinged around the idea of a cognitive audit for smart contracts. So static checking was brought up earlier, and static checking is an essential method in smart contract security, understanding who can call what smart contract and do what with it. There might be smart contracts which are airtight from the perspective of who can call it. Yet in the niche, interacting with cognitive entities or even other smart contracts, there might be destabilizing dynamics. So yes, there's the rug pull, the classical 2017 rug pull of like the devs have the method that they can do it. But then there's a continuum of more subtle and what could we have done rug pulls that anticipate how entities are going to interact with a deployed object. And so we do hope to develop for DeSci, for science settings, for DeFi and financial settings, for DAOs, governance and decision-making settings, this capacity to have like a test net or a real-time parallel stream, different ways that we imagine being able to take in system level parameters and use that to scaffold the adjacent possible in terms of what agents are bringing up, and then understanding how that's related to like risk assessment and scenario planning, decision making. So the cognitive audit angle will continue developing and are always looking for areas that people find like interesting or supportable. And then I guess one last thing that active inference could bring to cadCAD, it's possible that active inference will continue to develop and include many, many cognitive modules that otherwise might require essentially bespoke models. Like, what about models of action suggest that they would have anything to do with models of memory? Or what about hierarchical logical modeling would have anything to do with planning? With an integrated cognitive-ish framework, advances that are analytical or conceptual in active inference can have like a channel or a saddle point to be taken all the way to the implementational. And so then implementational advances will be occurring on the cadCAD side, and someone will also be developing analytical relationships or fleshing out different cognitive features on paper or even graphically. And then there will be a setting where those cognitive features can instantly be playing a role or quickly be playing a role in different kinds of cadCAD settings. And then on a more subtle or fun note, for some, there's so much interesting formalism development and mathematics development that has already occurred and is occurring, like connections with gauge theory, the Bayesian mechanics links brought up earlier. And so that will be fun to see how it comes into cadCAD. So those are what active inference brings to cadCAD, just a short list of that kind of entity model, which is providing that bottom-up view on DeFi, decision-making in DAOs, science, epistemic ecosystems, and so on. Computational advances related to deep model-driven sampling or even beyond that. And then this ability to bridge advances in cognitive sciences with implementational advances on the cadCAD side. So any thoughts or questions on that second part of what active inference brings to cadCAD?
I just want to say thank you so much to start off with. It's really exciting to see these two projects converging towards like making a technical handshake and working together on it. On the cadCAD side, that's exactly how we view our role in the ecosystems, providing basically the logic for all the for loops, as you highlighted. I guess the question, you've sort of touched on it in multiple ways, is how do you maybe see the workflow between like doing the cognitive agent behavior modeling in active Blockference, and then sort of validating or verifying that an agent behavior model as expressed in a cadCAD model where you have multiple agent policies sort of expressed. How do you see that connection maybe taking place? I think Jakob mentioned before Token Spice as an example for doing that kind of sort of thing for smart contracts.
Yeah, Jakob, you want to provide a first thought there?
Yeah, I think based on a conversation with Z, I think the reference implementation of cadCAD is going to be is going to allow quite a bit of interoperability with different tools. For instance, with Token Spice. So on the kind of, for instance, cognitive modeling side, where we could have one type of cadCAD simulation that runs different parameter sweeps across the generative model itself and then across the actions that the agent can take. You could have a token spice simulation in the loop where the agent interacts with wrapped smart contracts. And I guess I'm not sure whether I fully got your question, so I'm probably not answering it correctly.
I also asked it in a confusing way, so maybe I can reframe it. So there's the loop that you described with sort of working with a token spice or anything that can actually like represent Ethereum smart contracts and doing your validation against that. I guess I'm trying to draw an analogy between that and with active Blockference representing cognitive behavior modeling to do that for the representation of agents in cadCAD.
I'll give a thought. Thanks for the restatement. So I posted a link in the chat channel about our recent DSci paper where we proposed an ontology that will continue to be formalized, but this is an example of an ontology entity environment model that is compatible and starts to make that relationship occur. So to make it specific, if we say there are going to be three entities, three Goldilocks bears, the impulsive, the medium, and the long-term thinker, differentiated by their cognitive parameters, and they're going to be interacting with this other kind of entity. We'll specify the internal states, the action states that can be taken, the affordances, and then the internal logic of that smart contract. Where those smart contract simulation frameworks come into play is then their internal logic. So the affordance to send the token was a policy that was selected by the cognitive entity from its set of affordances in that system. And then that's going to trigger a wrapped logic of implementing that. That doesn't have to be an active inference model. Maybe in some really zoomed out way, you could think about the variables being passed inside, but functionally, we can just say, okay, the decision to send 1 ETH was selected by that entity 2. Then 1 ETH entering into a smart contract, given the system parameters, outputs that many of the other token. And then upon the sensory observation, state update to that entity, now here's how their cognitive model continues to unfold. And so we were intentionally general with that presented ontology because it can be used to assemble things like 2 DAOs decide to make a multi-sig with this many of n, and just the dream is, as also suggested in that screenshot provided, was people could use natural language to describe the kinds of systems they want to model. 3 friends are going to a restaurant and they decide to fund this based upon this governance mechanism, and then they do this with a multi-sig, but they're going to be using the ontology of cyber-physical systems, social systems. Those entities and their relationships, potentially even grammatically, can be parsed and then framed graphically as active inference entities. From the graphical framing, the question becomes, how do we execute and implement in cadCAD? And so we think that would close the loop with the ability to do rapid conversation, even driven with those who have different familiarities with different areas and skills, conversation driven assembly and modification of active inference situations that could be in a real-time loop with some plausible execution order.
Excellent. Thank you.
There's time for a few more questions if anyone likes. The meetings that we have for this project are on noon and 17 UTC on Wednesdays. So again, anyone can drop into our Discord or email activeinference@gmail.com if they want to be learning any more. Any other questions, or we can add a few of our little other notes just to have it in this recording so people might listen to them.
Yeah. Is there a work stream or project plan or anything like that for taking the things you've discussed and actually integrating them with cadCAD? Is there like active work being done, or is this all? Is it paid? Is it research based? Like, can you give me some maybe context on like what the actual next steps are here?
Yes, so we have a task and project-based roadmap. It is at this point entirely volunteer-based in a very small group. In fact, most of the cadCAD implementation was done by Jakob, and the small group of us who meet on this weekly rhythm, and for several months I've been developing it. We're actively looking for support to scaffold and steward those who are already engaged, and then also to help bring in other people. As to how we hope to build this bridge in Fusion, perhaps the most valuable would be those people who are in the learning group and using cadCAD to just drop by and listen and see those opportunities for contribution, and vice versa. Like, we always encourage our community to be learning cadCAD as well. And as to the exact workflows as we acquire resources for this project, we will work with that context to help clarify the reliability. But yes, it arose from a more research context. I've known Z for several years, and I'm a researcher, and saw how this could link to active inference. And as we develop increasingly relevant use cases, then those may become something different. But we also were very much inspired by the pattern of having an open source framework and keeping Active Blockference open source. Those who use it and are skilled in it will find ways to gain pragmatic value. However, it as a commons, along the lines of cadCAD as a commons, is a very important pattern. Okay, just to provide a few of the unsorted notes that we had on just like other random thoughts. We wanted to recapitulate some classic ActInf examples from the literature in cadCAD and just demonstrate this was done for this one point in cognitive parameter space. We just swept over all these dimensions of system settings and cognitive parameters. Personally, I'm interested in advancing cognitive modeling in ants and insects. So that's been one of the main directions. If anyone else is curious or loves insects, it would be super fun to work on that. Web3 and crypto. We're interested in various aspects of the Web3 space, like governance, funding, and financial science. And we want to have that kind of a Web3 framework brought in, probably from those who have been developing it and battle testing it. And some of our participants are already working on areas like the bonding curves and so on. Then just to close with a few of these like more open theoretical questions, we're curious what the Bayes graph structure is of cadCAD. For example, in an engineering graph, there are edges that don't represent what edges represent on a Bayes graph, and there are causal relationships that are not shown in that entity description. So we're very keen to understand the Bayesian or the general dynamical structure underlying even simple cadCAD settings, because we think that'll be like a keyhole to understanding how some of these more advanced methods play into cadCAD. We're interested in different topologies and partitionings of the perception, cognition, action, impact cycle. We wonder if the cadCAD model is compatible, incompatible, isomorphic with the way that action and perception is framed in active inference. And the frontier of perception and action research has been opened with the computational advances to explore just some very mind-bending areas. And we're also really curious about real-time uses of cadCAD, because many people believe that active inference will be important for real-time settings, whether humans interacting with robots or all these other kinds of cases. communication in cadCAD, cadCAD models with niche modification, and the role of cadCAD in multi-scale decision-making, governance, and meta-governance. Hopefully, this has been of epistemic and or pragmatic value to the listener or re-listener. We're available in our Discord, many of us here on this discussion, and really look forward to seeing where we can go, reduce our joint free energy.
Excellent, wonderful. This has been a really illuminating edition of the community call. So thank you so much for preparing for this call and talking to our community. And I look forward to really pushing forward the collaboration between cadCAD and Active Blockference. I think maybe one way is, as I know you've seen, Dan, the cadCAD wiki effort as we sort of scaffold that out and make, I think, the contours of, I guess, systems modeling knowledge more legible there. Finding, I think, ways to sort of point to each other's projects at, like, hey, these might be the integration points, might be sort of like a good kickoff there.
Awesome. So everyone's welcome, hopefully in Active Inference and in cadCAD, and that's very beautiful about this space. See you in the Active Inference Institute Discord. Bye, everyone.
Thanks.
Awesome.
This
Thank
was
you.
great.
Presentation, guys.
Bye, everyone. Take care.